So I'll just start with the acknowledgement of country. So in the spirit of reconciliation, the Statistical Society of Australia acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to the elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. So thank you so much for joining us in our webinar series. This is a joint event from the students and the Early Career and Student Networks from the Stats Society of Australia and also New Zealand Statistical Society Association. So it's a pleasure to have you all here, and today we have a pleasure to have Gordana Popovic talking to us about analyzing hazard surveys with mileage assumptions. So it will be a very interesting talk, and Gordana has completed her PhD in statistics and statistical ecology at the University of New South Wales in 2007, and has been working as a statistical consultant at Stats Central at the Uni of New South Wales, Sydney, ever since. So her focus is mentoring junior applied researchers to take a principal approach to quantitative research through teaching and collaboration. So it's a pleasure to have her, and she has a valuable experience to share with us today in the very important topic, as data is normally not as we expect it to be, or not as the theory tell us that we will encounter. So thank you so much, Gordana, for sharing your knowledge with us today.
Thank you so much, Daniela, for inviting me. It's my pleasure to be here. I might just leave this up another second. So in case you want to do a quick convenience survey while you're waiting for me to start, just so that we all kind of have an idea of what a convenience survey is, and then we might see the results a little bit later. Okay, so I'll step away from that. I don't have the QR code here. I'd just like to acknowledge that I live and work on the unceded lands of the Bedegal and Gadigal peoples of the Eora Nation. Okay, so I thought I might start a little bit with my career overview, just because this is an early career event and you might be interested in how I came to be where I am. I have been at UNSW since the beginning of time. I did my undergraduate here in the early 2000s in statistics and also in teaching. So I had a double degree, and then I did my honours in statistics after that. And then after honours, I was thinking about doing a PhD, but then I decided to get a job because I was a little bit sick of research, and I thought I would like to earn some money and be able to eat out and things like that. So I joined the Kirby Institute, which does a lot of research on infectious diseases, including HIV. And so I did some mathematical modelling of HIV there. Oh, I should say, before we get too far, please feel free to interrupt with any questions, like literally just unmute yourself and talk, or put it in the chat and Daniela might tell me if it's there, or I might see it myself. So just feel free to interrupt any moment. So after a year at Kirby Institute doing mathematical modelling, so not statistics, I missed statistics because I found mathematical modelling quite arbitrary. If you don't know what mathematical modelling is, it's like what they do for climate models and a lot of disease models, where they just go, well, I think the transmission rate is this, and then they just run like a partial differential equation to predict what will be in the future. But they don't use any data really in the models, there's not really any data. There's just kind of assumptions, but no data. And so as a statistician, quite frustrating to do. And so I thought, well, if I'm going to be doing, I did get exposed to a lot of kind of research adjacent, research and research adjacent sort of work. And I realized that I would need a PhD if I wanted to do interesting work in statistics. And the amount of stats that I knew wasn't enough. So I did a PhD. I went back to UNSW again. I did it in statistics and statistical ecology with David Wharton. And that took me quite a long time. I think it was probably 5 years in the end. One of those, I took 6 months off, so I guess it was 4.5 years. I did it in 4 years technically, but I had a 6-month break. And then at the end of my PhD, David had started Stat Central, and so I started working there. Now, Stat Central is a consulting service internal to UNSW. So we only work with researchers at UNSW to help them do their research stats. So I did that for about a year, and then I did a little bit of a postdoc again with David. When I came back from a holiday, and then I decided to go back to Stat Central, and I've been there ever since. And so at Stat Central is where I came across the problem that I'm going to talk about today. Oh, there's something in the chat. You can see my Teams pop-ups. How can you see my Teams pop-ups when I can't see my Teams pop-ups? That's very interesting. Okay. Thank you, Jeanette. I've closed Teams. Appreciate it. Okay, let's make sure. Okay, so this talk is about a lot of things, but one of the motivating reason that I did this work is to do with policing and First Nations people. So this graph shows the rates per 100,000 of incarceration of First Nations people in the blue, and then other non-Indigenous people in the orange. And so it's about 10 times, the imprisonment rate of First Nations people is about 10 times the non-Indigenous people in Australia. And so so it's about 2% of First Nations people are in prison at any one time. And if you think about that cumulatively, you end up with things like about a fifth of First Nations men aged over 35 have been incarcerated at some point in their life. So 1 in 5, so if you think about 5 people in your life, one of them will have been incarcerated. But I don't know anyone who's been incarcerated, and many of you won't. So it's much more common among First Nations people to have been incarcerated. What are the causes of this? So, entrenched social disadvantage. So, lack of stable housing, lack of educational engagement, lack of meaningful employment opportunities. A lot of that has to do with intergenerational trauma. So, the educational opportunities are because people had very low expectations of people, of First Nations people, and they may still, and so they did not get the same opportunities as other people get, and then their children might not get the same opportunities because they don't have the same educational background. And so there's an intergenerational part. And then also there may be structural and systemic factors, including laws and policies and practices by the police, lawyers and judges that might impact this. So this part is the part I can't do anything about this, and I can't do anything about this either, but this is what we're working on. We're thinking about practices by police and to see if they impact this sort of overrepresentation of Indigenous people in the criminal justice system. Okay, so the question is, do police in Australia racially profile? We don't know, so evidence requires data, and the police really tightly control their data. So they've historically never released data that would be able to be used to assess this question, to answer this question. There was a quite famous case, the Hale-Michael case, which was led by my collaborator, Tamar Hopkins. And the data was actually analysed by Ian Gordon, who many of you will know, at Melbourne Uni. And he was the statistician for the defence, the prosecution. And so he was able to get data from, so he got confidentially data from the police and was allowed to analyse it and present results. And so some of his results, this particular case has to do with African appearing people, so not Indigenous as such, but it's sort of indicative of the same trend. So he's found that children and young people from African and Middle Eastern backgrounds are subject to 2.5 times more field contacts than predicted by their population proportion. So a field contact is where the police sort of just say, oh, hey, what are you doing? So they don't really they're not arresting you. They're not, doing anything very formal. It's just a contact. They're sort of asking you, they're approaching you and then they're talking to you. So people from these backgrounds are much more likely to have field contacts. There's been also some other data that's been released. So in WA, so the Hale Michael case was in Victoria. In WA, there was some traffic enforcement data where it looked at fines received from police officers versus through traffic cameras. And it found that police officers were more likely to give fines to Aboriginal people than were traffic cameras. And so that's some evidence of racial profiling that we have. Okay, so this case was really, really important. It settled in 2015. So basically, the Victoria Police released these data to just to Ian Gordon, and he analysed them. And the data had in it field contact. So whenever the police went up to somebody, talked to somebody, approached them, they would write they would put it in their app. And so it had this data. And so then the Hale Michael case settled, so they had to pay compensation. And in response, Victoria Police decided to change its policy to no longer actually record that field contact data. So they continue to have field contacts. They continue to have more of them for people who are, African American or African or Middle Eastern appearance, but they just don't record that data. So that data no longer exists. We can't get it because it doesn't exist. It could never be analysed from here on in. So that was a very big disappointment for the people that were working on this case. Okay, any questions so far? No?
Nope, all good.
Thanks, Alberto. Okay, so police and racial profiling. So we want to think about how we can measure racial profiling. This is one way to do it. So, for example, police might stop pedestrians either when they see them committing a crime. So like this picture up here. So that's non-discretionary. We're calling that non-discretionary. The police have no discretion. They see a crime committed, they have to intervene or try and catch the person. And then the other type is discretionary, which is kind of this picture down here. Someone looks suspicious, and so at their discretion, they can decide whether or not to contact that person, to talk to that person. And so what we want to know is if racial appearance of a person increases the police officer's likelihood of stopping a person when they have discretion. Because the non-discretionary ones they have to do regardless, but the discretionary ones they get to decide. So we want to know when they have discretion, are they more likely to stop somebody who is, of Aboriginal appearance or of African appearance or whatever. And so what we're going to do is, we're going to use these non-discretionary stops as a baseline, and then see if the proportion of racialized people is higher in the discretionary stops than in the non-discretionary ones, then that would be considered to be evidence of racial profiling. So that's how we're going to do this analysis. Okay. So what are we going to do? So given the police no longer actually gather this field contact data, it doesn't exist, they never write it down. They also don't really search data. So they do gather search data. If they have searched somebody, they have to have a record of that. But until recently, that also wasn't released, although there are some, Tamar Hopkins has gotten some FOI requests where she has some of these data. So what Tamar did is she created a survey to try and get at this question. And so she asked people about, what is your racial appearance? What kind of interaction did you have with police? And then she looked at those interactions and she classified them as either being discretionary or non-discretionary. So we have those two variables from this data set. And then she distributed this on Facebook. She distributed it to the Flemington and Kensington Legal Centre, the Victorian Aboriginal Legal Service, and through her staff contacts at various sort of legal centres around the place. She also put postcards in public libraries and did a paid ad. So her strategy was aimed at essentially oversampling people who needed legal advice and people who were Aboriginal and other multicultural sort of people. So this is in no way a random sample of anything. It's a very, very biased sample by design, essentially. Okay. And this is what's called a convenience sample. So Wikipedia says it's a type of non-probability sample that involves samples being drawn from a part of the population that is close at hand, which is kind of an interesting way to say that, but basically any sort of easy to get sample of people. So examples of this kind of thing are Qualtrics that have pools of paid participants, or you can interview people that pass by you, or you can advertise on social media like Tamar did. And these are all convenience samples. Okay, so can I have a show of hands? Anyone that learned in their undergraduate how to deal with a convenience sample, like how to analyze samples that were not random samples from like a survey that wasn't a random sample? Was there anyone? I'd be very interested to know. No one, I think. What about after that? If in your masters or PhDs, or if you did any of those kinds of degrees, does anyone had any training on how to analyze? Ian did. Ian, I'd be very keen to know where you did. You can type it, or you can just unmute.
Never actually had any formal training in this. It was more, I was brought a number of these samples, particularly when I was doing the consulting role at the University of Canberra. Mm-hmm. And the bottom line is that we tried a few things to sort of say, well, okay, can we make this into something that looks like a convenience, looks like a probability sample, i.e. Mm-hmm. by matching to a sort of a known group, and sort of say, so you've got a one-to-one, a sort of a case control sort of match.
Yeah. And
that was about the closest we ever came to sort of saying, look, yeah, okay, there's something we can do with this. Yeah. But the bottom line is that, yes, I used to steer them away from that and sort of say, look, go with descriptive statistics, and that's about all you can do.
Yes, absolutely. I think that's probably a super common experience for consultants, Ian. Okay, so I never got any training whatsoever in convenience samples. Okay, Chris kind of sort of are working in marketing, and yeah, okay, but not formal training. Okay, so how common are convenience samples? When you start working in applied statistics, they are way more common than other types of surveys. And so you can see, like, from these examples, like convenience sampling dominates social science research, this caregiving research, in developmental science. A lot of research areas rely very heavily on convenience samples. And no one will tell you that's a convenience sample. So when you're kind of a young early career person and you come across somebody who's like, I've done a survey, can you help me analyze it? And you think, okay, I'll just do a logistic regression or something. You have to really stop and think and go, is this actually something I should be doing? So that's kind of the first thing that we need to do. And I think I'm guilty of not having done that in several instances where I just kind of went, okay, well, here's a regression and you can do that. So it's, none of us got any training on it, but it's a lot of applied statistics is, a lot of people have convenience samples, convenience surveys. Okay, so what Ian was getting at is definitely what people in research tell you to do. So if you have a convenience sample, you might be able to adjust it or correct it if you have some sort of auxiliary information. So if you have a reference survey where you kind of can match the proportion of, you know, each sex and so on. And so that's a good way to go, because you can kind of, there's various different ways of doing that, but they all kind of amount to the same thing. You're kind of correcting your convenience sample to more closely seem like a random sample. Let me just read some of these other. So Sue says most surveys are convenience samples. And Monique says on the ethics committee, we see a high proportion of convenience samples. And then Jeanette says a lot of the work in experimental psychology. Yeah, so it's just kind of a hand-wavy argument of it being non-convenience. And then market researchers. Oh, so market researchers often wait to some population to correct it. That's interesting. Yeah, okay. Yeah. Cool. Okay, so a lot of people have had experience with this. All right. Okay, so this convenience sample, I was very keen to analyze it because of this background, because there is no data. The data doesn't even exist. Like, the data is not recorded. It can't be even, you know, freedom of information requested because it's just no longer recorded. So there's really no way to get the data or a sample of the real data. So we kind of have to go to the community and try and get it from the community. And how to get a random sample from this community with no budget is unclear. So this is the data that was here, and I was really keen to analyze it. So the recruitment strategy, whether or not I was right in analyzing it is a question that I still don't have an answer to. Okay, so the recruitment strategy was deliberately targeted to increase the chance that Aboriginal and other racialized people would encounter the survey. Racialized just means anyone who is impacted by racism, basically. So it can be any group. So what we're going to assume is that the response rates differ by racial appearance because of the recruitment strategy. The stop type might also impact the response rates to the survey. If I feel like the police are hassling me and I see a survey about the police, I think I'm more likely to answer that survey than if I'm committing a crime and the police hassle me, because it's like, well, I was committing a crime, so what are you going to do? So that might be the case, and so we don't want to make an assumption about that either. Okay, so what we want is the population of interest is all persons having a field contact with Victoria Police, and we do not know the structure of this population. We do not have any auxiliary information. We don't know the age, sex, the racial appearance structure of our underlying population because the data is not released, and since Hail Michael not recorded. Also, racial appearance isn't something we can match for even on population data because there is no systematic records for racial appearance. So, for example, a lot of Aboriginal people may not appear to a policeman to be Aboriginal. So it's racial appearance that we're really interested in rather than, ethnicity. Okay, so what do we do? So we wanted this association between discretionary versus non-discretionary stop types and racial appearance. And we'll just, for simplicity, make racial appearance binary here. So it's either going to be racialized or not. And that's one way to do it. And then we also have some covariates. Like, we know that survey response rates differ by age and sex, but also the stop type might differ by age and sex, as in, like, depending on age, some people might, like, the police may not approach older people, or they may be more likely to approach younger people or younger men and so on. So there's all kinds of covariates going on. Okay, so what I started doing is just writing things down. And so many of you will be familiar with outcome-dependent sampling. And odds ratios. So this comes up a lot in health research when people do case control studies. In case control studies, you sample based on your outcome rather than based on a predictor. So say you're interested in does smoking cause lung cancer, you don't go out in the population and record who smokes and who doesn't, and then see if they have lung cancer. In a case control study, you go to hospitals and you find all the people that have lung cancer, and then you find controls for each of those people who don't have lung cancer, and then you compare their smoking statuses. So that's a case control study. And a long time ago, people found out that if you use odds ratios, it's fine. You're not going to have a problem. So if you use, for example, relative risk, you can't use that with case control studies because it depends on the sampling, on how many people are sampled and what proportions. But if you use odds ratios, it doesn't. So, so here is, on the left is a 2x2 table of probabilities. So here is racial appearance, 0 and 1, doesn't really matter, Caucasian and racialized, and then stop type, this is non-discretionary and discretionary, and then this is just the probabilities in each of these. And then this table is not a 2x2 table, it's just a convenient way for me to summarize these response probabilities. So this PR given 0, 0 is the probability of responding to my survey given you are in this group. So what I'm going to do is, because I'm going to assume that my sampling is outcome dependent, what that means is that the stop type is my outcome. The response rates are going to differ by my outcome. So they're going to not differ by my my predictor, but they are going to differ by my outcome. And so it looks like this. And so if you plug that into the odds ratio formula, you find that these alphas cancel, these p-naughts, so a lot of this stuff cancels, and you end up with just the odds ratio. So even though, so this is the odds ratio you would have gotten from a random sample, and this is the odds ratio you got from this outcome-dependent sampling, and they're the same. So this has been known, I think, since the 40s, and it's a very nice property of odds ratios. You can do the same with predictor-dependent sampling. So here, you can see that I have different probabilities of response depending on my predictor, but not on my response. So if you sample according to your predictor, so I'm going to sample 100 people that smoke and 100 people that don't smoke, or 200 people that smoke and 500 people that don't smoke, this is kind of what you're going to get. And this is actually always true for this is even true for a relative risk or pretty much anything in statistics. You can condition on the predictor and everything's fine. So if you plug that into the odds ratio formula, you find that even if you did response based sampling, predictor dependent sampling, you are going to get the same odds ratio as you would have for your random sample. So this is all nice, but we are in the position where we have both. So our sampling depends on both the outcome and the response. So we can see that we have different, when stop type is 0, we have 2 different probabilities of response to the survey. And then they also change according to the outcome. So this becomes alpha that, and this becomes gamma that. So these 4 are all potentially different numbers, and I've just written them with alpha and gamma to make it easier to do some maths. So if I plug all this in, you'll find that the odds ratio that I estimate from my convenience survey is the odds ratio I would have gotten from a random sample times this gamma over alpha thing. And you can see gamma and alpha are these sort of multiplicative so how much the probability of responding to the survey is multiplied when you go from stop type 0 to stop type 1. Okay. And so what does this tell us? Well, it tells us that if gamma and alpha are the same, then these two are the same, right? So if gamma equals alpha, we're all right. So odds ratios are not biased by selection if alpha equals gamma. There's lots of ways to think about this. So stop type, if stop type changes the response rate by the same amount, regardless of racial appearance, where that change is multiplicative. So I'm multiplying by, if I multiply by the same constant, as I go from stop type 0 to stop type 1, then I'm going to have no problems using like a logistic regression to find an odds ratio. Another way to think about it is the response rate can depend on both the outcome and the predictor, but not the interaction between them, where you are specifically thinking of interaction on the log scale. So not a logistic, so yeah. It's a particular kind of interaction because this is kind of, it's a multiplicative, so the probability increases by a constant. Okay. Any questions? Did I go through that too quick? That makes sense. Any questions about that? No questions, no thoughts. Alberto, you are the best audience in the world. Okay. So, all right, so what if we have covariates? So I've just shown you what happens, you know, if we have if we have this 2x2 table, what happens? But what if we also have some covariates? Well, when you have the traditional outcome-dependent sampling, so not what we're talking about, but just the outcome-dependent sampling, like a case control study, you can still you can still just do it. So basically, you don't need to worry about covariates. You do have to, obviously, you have to control for any covariates that impact your outcome and response, like always. You also have to control for any variables that impact sampling. So even if they don't impact both your response and your predictor, so they're not technically confounders, you still have to control for them because they impact the sampling, and so that still has to happen. So what we want to know is this also true for when we have both outcome and predictor dependent sampling? So what we want to know is, can we still apply the formulas above to obtain a population estimate? Oh, very, very poor typing here. So we want to know if like the odds ratio we would have gotten from a random sample, if we can use our model estimate from the convenience sample to still calculate the odds ratio from a random sample, even if we have covariates or confounders. And it turns out, at least in my simulation, that yes, we can. So I don't have a proof of this, working on that, but I did a little bit of a simulation. So this is a DAG, which makes people think of causal inference. So first of all, I'm not doing any causal inference here. I just like the clarity of a DAG in terms of what I'm doing. So everything I'm doing here is associations, not causal at all. But essentially, we've got we've got our outcome, and we've got our predictor. And in my simulation, I've done it so that there's an odds ratio of 2, just to keep things simple. And I've said that the response, like whether or not you're going to respond to a survey, depends on my outcome. It depends on my predictor, and it also depends on some covariate here. Okay, and then that covariate is also a confounder in this simulation for the relationship between X and Y. So I have to control for it regardless, but even if I didn't have this, I still need to control for it up here. So, so what I get is, if I do the simulation, my odds ratio is 2. So if I have a random sample, if I simulate a random sample, I get a nice little tight box plot around 2. So my odds ratio, so this is, you know, fairly good. I'm fairly happy with this. This is estimating the correct odds ratio, as it should. And then I can do a couple of things. So say that I have a convenience survey, but I have alpha equals gamma. So that means that multiplicative constant is the same for racialized and non-racialized people, which I might just show you again. So this alpha and this gamma, this alpha multiplies this probability of response, and this one multiplied this probability of response. So if I have these be the same thing, then I get the right estimate, even from my convenience survey. If I simulate it slightly differently so that I have alpha and gamma not the same thing, but I have some other ratio between them, I'm going to not get the correct odds ratio, but I'm going to get the biased odds ratio with the correct bias, i.e. the odds ratio that I'm going to have from this convenience survey is going to be the odds ratio I simulated times the gamma over alpha. So if I wanted to, I could then just multiply this by alpha over gamma, and I could move this down here and still get an odds ratio that I need. All right. Questions? All right. All right, so then what can I do with this? Like, I don't know alpha and gamma. I don't know what they are. I don't have any auxiliary data to do anything to actually estimate, alpha over gamma or anything to do with that. It kind of is like a fairly reasonable assumption, I think, maybe, that alpha equals gamma. It's sort of like a higher order interaction, it may be reasonable to assume. But if I'm going to assume that, I want to know that I can communicate that to both my collaborator and the people reading this paper. But this paper is going in a legal journal, and they see almost no quantitative content, and even less actual statistics. So even like the idea of a logistic regression, the idea of p-values is completely foreign to them. So there's a whole paragraph explaining what p-values is in our methods. In our methods, there's also a confidence interval paragraph, because people just reading this will not know this. So this is like a very naive to stats audience. So then I've got quite a complex analysis with quite complex assumptions that I have to communicate to this audience. So did I do that well? I don't know. That's an open question. But I talked a lot to Tamar about why people may or may not respond to the survey and how we can communicate this. But also I wanted to, so this, I thought about this since the first time I presented this survey. This talk earlier in the year. I was doing some tipping point analysis for another study I was doing where we were doing, they had some missing data and we're doing multiple imputation. So if you're not familiar with tipping point analysis, it's very often done when you have missing data and you impute data because you're imputing it under an assumption of missing at random, but that assumption may not hold. And so tipping point analysis sort of changes the imputed data in a way that reduces the effect. And we sort of try and figure out how much we have to change the imputed data to no longer be able to, find an effect. So a p-value greater than 0.05 or whatever. So they're really useful because you can kind of at least think about how much the assumptions would have to be violated by in order to negate the results that you found. So I thought that we might be able to use this for a tipping point analysis. But that's going to be even trickier to communicate. Okay. I wrote a bunch of stuff. This is not what I wrote in the paper that we published because I've been thinking about it since then. Probably don't want to read all the grey stuff, but I think the important stuff is probably in black. So it's important to note that we don't need to assume that people, that the two racial appearance categories have the same response rate and the two stop type categories. So that's something. And then I go into here about, what alpha and gamma are. And then what I want to say is something like, if alpha equals gamma, so racial appearance and stop type act independently on response probability, we can report odds ratios from a logistic regression. And that's what we've done. And then in general, an unbiased odds ratio is the estimated odds ratio multiplied by alpha over gamma. And I have an appendix where I explain what I've just told you in this talk. And then I guess what I want to say is we don't have any data from which to estimate alpha and gamma. And hopefully I've given enough information to the reader in these paragraphs to say, so they can sort of intuit what these mean and be able to sort of get meaning from it. Okay, but I guess what I want to do is make it very clear that we are making an assumption, a strong assumption, and what the assumption is. So this first paragraph is what we wrote in the results. So if we can assume that racial appearance and stop type act independently on response probability, the odds of police officer stopping a racialized person for a high discretion stop rather than a low discretion stop is about 2.8 times higher. Now, if you were paying attention, 2.8 is pretty close to that estimate that, that Ian had. It was a slightly different question, but kind of quite related. So it's not an outrageous estimate. He did a relative risk, not an odds ratio, but we know that they can be quite close. Okay, so then I thought about, can we do a tipping point type analysis? Well, it's actually very easy because we know that this confidence interval, you know, the p-value will become non-significant, quote unquote, if this goes below 1. And I know that my alpha and gamma just multiply the odds ratio. So I can, if I divide this by 1.53, I know I'm going to get 1 for this lower interval. And so that makes it pretty easy to say what the tipping point would be. So if alpha is greater than 1.53 times gamma, and then, you know, we can sort of try and say that in words. So if the increase in the response rate for discretionary stops relative to non-discretionary is 53% higher for racialized people than Caucasian appearing people, we would find no evidence of racial profiling. Otherwise, we do find evidence. So that is my attempt at communication. I think the communication part is by far the hardest of this. So should we analyze convenience surveys? Well, maybe some of you would have done, I hope some of you did my survey. So I'm going to see if I can read that data in. Oh, every time I do this, it's very strange. So let's see what the odds ratio is. The odds ratio is in the opposite direction to what I thought it would be. So my intuition is that people who are sort of methodological, who don't do a lot of applied statistics, might not come across convenience surveys, and so they might think, oh, I don't really want to analyze them using inference. Whereas people like me who do, you know, consultants who do a lot of this stuff, you know, you come across a lot of them and sometimes you're like, well, I really would like to analyze them. So, but it's actually the other way around. So the methodological statisticians had a slightly higher proportion in my convenience survey. And you might want to think about what assumption I have to make in order for that odds ratio to be valid. So the question is, does knowing the assumptions help? I think for me it helps because it gives me quite a good intuition of what's going on and what might be the case. But I don't know, in terms of communicating it to applied researchers, I have no idea if that actually helped or if it was just a bad idea and they're just going to take the odds ratio that I gave them at face value, probably. I think the tipping point analysis is also helpful to get an intuition of how much off I would have to be on my assumptions. But there are also unintended consequences. So one of them is that Tamar was doing a PhD at the time, and one of her examiners actually in their examination report really loved this idea, and his takeaway was that, oh, well, then we just need to do convenience surveys from now on and we never have to do random surveys again. which is the exact opposite of what I want people to do. So definitely possible to have unintended consequences from doing this kind of thing. All right, so that's me. Any more questions? Okay, so I have one question from somebody who's anonymous. Why not conduct a more traditional approach to survey sampling approaches and do a random postal address letter drop or linked with Flemington Council rate notices and ask the same similar questions? Yeah. Yes. I don't think it's a bad, I mean, I think that's a good idea. I guess the problem was that when I came along, the survey was already done. So I had no input in actually doing the survey at all. And so I just had to come up with a way to try to analyze it. But yes, even if you're doing a sort of more traditional survey response that's less convenient, you probably would do a bit better. I guess you need to have enough people that have actually come into contact with police, and that's quite hard to find in any sort of random survey. But I certainly take your point, whoever you might be, anonymous person. Any other questions or thoughts? I have some open questions here, so I would certainly be interested in thoughts of those people, many of whom are more experienced than me in the audience. Oh, do Bayesian approaches offer any possible alternative methods here? This is from Bill. Can you come up with a plausible prior for alpha over gamma? I had not thought about it. I'm not a Bayesian person, but it's not a bad idea. Yeah. Okay, a prior. Why not? What would you get? So a prior. Yeah, so I guess even for a prior, you still need, I mean, that's kind of related to the, adjusting for weighting or whatever, like a propensity type scores, because you still need some data, I guess, to sort of inform your prior or whatever it might be. Rob says, thanks. Rob wants to know about my statement about only being interested in associations, but if they're not causal, are they really interesting? Good point, Rob. I guess it's just another level of difficulty that I just haven't kind of come up with. So yes, absolutely would love a causal interpretation, but I think I would need to control for quite a few more things to be able to go that way at all. Okay, Chris says, do you think such a traditional approach might still have strong response bias as you outlined? For example, people who have contact with police are more likely to answer. Yeah, okay, yeah. So this is in response to the person who said earlier we should do a random postal address. Yeah, that's a good point. Yeah, you might still get the same biases anyway. Absolutely. You can also unmute yourself and have a chat. Sorry, my phone is ringing. Just quiet that down. Okay, looks like no more questions, comments. Anyway, email me if you have thoughts. I would love to hear from anyone. All right, thank you, Daniela.
Thank you, Gordana. It was a very interesting talk, giving us a good way of putting scenarios, and seeing what you would do if different things happen. Tipping point is actually something very interesting to see as well there. So thank you so much for showing us, and as well as exemplifying how to communicate with an audience that might not be used to. So it's a great talk. Thank you so much. Very interesting methodology and way around the practicalities of real life data.